High over the Bay of Biscay, the flight is running smoothly and to schedule. Captain Steely takes the opportunity to update the passengers on the weather at their destination.
The weather forecast for Malaga for our arrival, a light south easterly breeze with good visibility, a little bit of low cloud but nothing much, and clearing up as the temperature increases during the day, and by the time we get there I reckon the temperature will be 18 or 19 degrees Celsius, the high 60s or the low 70s Fahrenheit. So please sit back, relax, enjoy the remainder of the flight, enjoy the video show, and I'll speak to you shortly before we commence our descent into Malaga. Okay, back with you.
The crew continue the task of monitoring the systems as the flight reaches the border of Spain. One of the benefits of the new Airbus computer technology is the drastic reduction in pilot workload during flight. So what are those computers doing? A fly-by-wire aircraft is steered and maneuvered by electrical signals from the flight deck. Concorde had an early non-computerized analog form of fly-by-wire, but the concept had remained dormant on civil airliners until it appeared on the A320 series. On conventional aircraft, complicated systems of levers, rods, wires and hydraulic pipes provide a mechanical link between the pilot's control columns and the control surfaces of the aircraft, like the ailerons and elevators. Like power steering on a car, the hydraulics take the effort out of controlling the aircraft. It's a reliable system if it's well maintained, but it is heavy. On a fly-by-wire system, all those linkages are replaced by computers and electric circuits. When the pilot's control column is moved, the computers send an electrical signal to the hydraulic jacks, which move the control surfaces. With no physical effort now involved, the control column itself has been replaced by small electrical side sticks, providing more legroom and an unobstructed view of the instruments. To ensure safety and reliability, the fly-by-wire system is designed around no fewer than 5 computers. Each one is made up of 2 parts, each half constantly monitoring the other for faults. Although each computer is responsible for separate control surfaces, it's possible to control the aircraft with only one of the 5 working. As a further backup, mechanical links are still in place to the tailplane, trim and rudder. So in the event of a complete computer failure, estimated to be a chance in a billion, the aircraft can still be flown. With so much new technology, it is important to train pilots thoroughly to fly the Airbus. Training takes about as long as converting pilots from one commercial aircraft to another, around 30 days. Although a little confusing at first, most pilots soon find the Airbus flight deck has many advantages. But the airlines themselves were initially slow to realize the potential of fly-by-wire.
Fly-by-wire is a new art form. It's rather like the difference between a word processor and a typewriter. If you know how to use it, it can do lots for you that the traditional equipment couldn't do. But if you don't know how to use it, it's going to confuse you. The airlines failed, and I think this is criminal of them, they failed in the early days to take the fact seriously that pilots would need additional training going on to fly-by-wire, because they were going into some completely different world.
The financial benefits of this new world of fly-by-wire to airlines are enormous. The use of electrical wiring rather than steel cables results in a huge weight reduction for the aircraft, making it lighter and more fuel efficient. Maintenance too is easier and less costly. But a far more significant plus to come out of the use of fly-by-wire technology on aircraft is a dynamic new safety feature, flight envelope protection. There are physical limits to what any aircraft, large or small, can do. They can't fly too fast or too slow, climb too sharply or bank too steeply. These limits are called the flight envelope. On the Airbus, if there is ever a risk of these limits being reached, the computer systems automatically take action to prevent disaster. Because the computers are always standing by to correct faults, pilots can use the aircraft's potential to the maximum. Here, a test pilot is deliberately trying to stall the aircraft. Nose too high, speed too slow. the computer won't let him overdo things. It keeps the aircraft just within its flight envelope, allowing the maximum nose-up attitude that is possible without stalling. But all this technology doesn't mean the A320 is impossible to fool. Sometimes, even the best safety systems can't save pilots from themselves, as happened at the Habsheim Air Show in 1988. Flying low across the airfield, the pilot had slowed down almost to a stall. With the undercarriage down, the computers interpreted the pilot's actions as a landing. Suddenly realizing the width of the field was less than he'd expected, the pilot tried to take evasive action.
They pulled the stick back to try and get the aeroplane's nose up, and then the aeroplane's protection system came in. The aeroplane pulled its nose up as far as the computers would let it without stalling it. Okay, so he's getting maximum possible lift out of the wings, and that was the computers that were preventing him from stalling the aeroplane. But the engines were too late. Just as full power started coming in, they started swallowing lots and lots of pine forest, and that doesn't make engines work any better.
Checks showed there was nothing wrong with the aircraft systems. The extra safety and the savings provided by fly-by-wire are now too great to be ignored by the world's aviation industry at large.
When today's non-fly-by-wire airplanes have finally gone out of service, we'll never see non-fly-by-wire airliners again. So when the Airbus A320 came into service, a new era was starting. The last big airliner, the last brand new big airliner which is going to be built or introduced this century is Boeing's 777. And with that aeroplane, Boeing has entered the fly-by-wire field itself, and it will never depart from it.
Back on board the A320 of Monarch Airlines, the descent towards Malaga is underway.
Sure, the video's... Okay, it's idle now. Having reached the profile, the engines are now going to come back to idle. We're going to continue the rest of the descent profile with the engines at idle. We're going down, I've selected 10,000 feet, because that's the altitude to which we're cleared. Okay? That actually comes up on my display here as flight level 100, which is 10,000 feet, blue, because it's pilot selected. If it was computer selected, and there are altitudes in here which I've given it, then it would come up magenta. So it's to distinguish between who's actually controlling the limiting altitude at the time.
Up ahead, the sensors have detected some unsettled weather.
A little bit of rubbish there. Yep. We go right 10, just for 10 miles. So we take us past that bit of weather and then in through that gap. It should be nice, shouldn't it? Okay, that's speed, vertical speed. That's idle, open descent heading.
Check.
Okay, there's 18,000 feet. The seatbelt signs are on. The MSA check. Worst case 10.1. We can go down to 70, but once we get back on track, and it's 5.5 past the beacon. 10,000 within 25 miles on the airfield plate. Right, I'm coming back now.
Check.
That's managed, Director Martin. Just tell him we're going back.
Malaga, Buenos Dias, it's Monarch 012, descending 100, inbound to Martin.
Monarch 012, Buenos Dias, confirm clear of clouds.
Confirm.
012.
Okay, now you may proceed on heading 170, initial vector to the localizer at runway 14, expect no delay and clear downfield level 80 initial.
Okay, heading 170, cleared 80 for the localizer 14, Monarch 012.
Idle, open descent
As Monarch
heading.
012 nears Malaga, the instrument landing system is activated.
Golf Mike Mike, the ILS identifies.
Confirmed.
I've set QNH altimeters.
019 is set, 8,000 feet now, 5500 blue.
Check, MDA is 275. Approach checks, please, Rob.
Altimeters,
Okay, they're checked.
seatbelt signs,
Are on.
engine mode selector.
Is normal.
And 2 to go, checks complete.
Two go check.
As the airport approaches, the flaps are extended in stages to increase the surface area of the wings and slow the aircraft
Good
down.
to go. Gear down.
3 greens.
Thank you.
Landing checks when you're ready, Dave.
Yes, please, landing checks.
Auto thrust.
It's speed.
Landing gear.
Down 3 greens.
Spoilers.
Armed.
And the flaps.
Arm full. All the pilot coming out.
In the final stages of landing, an electronic voice warning tells the captain how quickly he's descending.
50, 30, 20, retard. Retard.
Manual braking.
012, spectator.
012, Roger, continue Delta 6.
Delta 6 with the follow me, thank you.
Captain Steely taxis the Airbus to the gate at Malaga. Just about the only time in the flight, this extraordinary aircraft ever gets close to being anything like a bus. Following shortly, Untamed Africa follows 2 million herbivorous creatures on their migration from south to north.